So now let's dive into the code, and let's look at what are we going to cover in this uh, and I have I'm using the Collab notebook. You can use any Jupyter notebook which you want, but I'm using the Collab notebook for this. So the first step is to implement or run all this your library files and packages. So that's what you're doing. I'm just defining a base path because this is the way I've put the files in the in Collab, and so this is the base path, and listing down all the data which is your pothole images. I'm listing it down here. Now let me try to visualize some of those images which has got these potholes. A few of them, 3 or 4 of these images are visualized here. So you can see the images with the potholes here. Okay, and we will also have the negative images, which is images without potholes. Normal roads with good roads and vegetations, etc. That's our negative classes. And we will also now look at the CSV file. The CSV file is has all the information about the potholes. Then it has got its bounding boxes also. So we created these bounding boxes, if you remember, in the second post. So you can see all those bounding boxes also which you have created. So all these information are there in the CSV file. So we will load the CSV file also. Now what we do is next we will find the mean of these the bounding boxes, the mean of the x dimensions and the y dimension. Now why you want to do this is it will come later. No, when we do the hog features, we need something called a window dimension, and the window dimension is which looks at the dimensions in which the potholes occur. Okay, the common dimensions in which, or the window in which the pothole will occur. So what we'll do is we'll take the mean of all these all the x dimensions, or the x axis and the y axis of these potholes or these annotations, and then we'll kind of round it to a rounding it off into a integer form. That is, we'll adopt an 80/40. So it all depends on your the images which you have selected. Now the images which I had selected were of these dimensions, and that's what I adopted. So probably your dimensions also could be much different from this. So you have to stick to a dimension which is based on your distribution of images which you have selected. Okay. So having seen the hog features, now let's look at a function which uses the hog features to extract features. So as we said, our primary method for feature extraction is through the hog features, and we'll wrap it up in a function to do that, so that so that we can do it again and again. So this is the function for extracting hog features. So you have the image, the orientations, pixel per cells per block, and the normalize as parameters. Now the first step is to extract the features. Now for extracting the features is through a method called feature.hog, and so you give all those parameters as the input to this method, and here we are just clipping any of those features which are less than 0 to 0. You're just clipping its value to 0. That's what we are doing, and we return the feature. Now we'll have a look at one more important function which we'll be using. Now remember, when we discussed upfront, we had only very limited images of potholes. Now one method to one method to increase the number of images is through a method called augmentation. That is, you're augmenting the images which you have so that you have enough data to train with. Now, augmentation have to be very careful. Now, there are different methods of augmentation, like you can flip it horizontally, you can flip it vertically, you can rotate it, you can shear it. So there are different methods for orientation of these or augmentation of these images, but we have to be very careful about the images which we are going to what kind of method are we going to use to for augmenting and what kind of augmenting what kind of images. So depending on the images, we'll have to determine what kind of augmentation methods we can do. So let's look at that function. So we have wrapped the whole augmentation process into a function. Let's look at this function. So image, this is the function, and you have the inputs are the ROI. ROI is the region of interest. So earlier we saw that we drew the bounding boxes using the labelImg, and then using the bounding boxes of the potholes, we extract the ROIs. Then you want the height and width of this. So this is basically your window, the standard window which you extracted earlier, like this 80/40 which you had determined earlier. So that's what we'll give. There is one more flag which we give us, whether it has to be an extensive augmentation or not an extensive augmentation. So default value is true. We'll come to what is this extensive and non-extensive augmentations once we go through it, and why we use that. So the first is to obviously to open a empty list, store all the ROIs, and then we have to resize our image to the window width. Okay, we are just resizing using the OpenCV method CV to resize. And so once this is resized, so this is the first image, we append it to the list. So now the first augmentation which we are going to do is the horizontal augmentation. So the augmentation, so OpenCV has got a inbuilt method called the flip method, which you can flip it. So this is the parameter which determines how the flip is done. So parameter called 1 is flipping on the y-axis, that is this axis you're flipping. So when you flip, you either flip this side or this side. So that's the, so you in turn you have a horizontal flip by giving the parameter 1. So that's the first flip which we do. So why this horizontal flip is not part of this if extensive is because any images you can flip horizontally, it wouldn't change much. But in this extensive flipping, we would do only those for those images when flipped doesn't change the basic structure of the image. Say for example, so the first kind of flipping inside this extensive loop is the vertical flip, which is determined by the parameter 0. Now let's look at for a pothole, if you flip it vertically, it doesn't matter, whether it is this side or this side, doesn't matter. But what if we flip let's say a car? So that's what we need to have. So if you flip a car horizontally, it's okay, but if you flip a car vertically, then it doesn't make sense because you don't have a vertically flipped car. So that's why for only those images which wouldn't change the structure of that image or the object which we are trying to detect by these kind of flippings, that is your vertical flip, then you're rotating it clockwise and rotating it anti-clockwise, and then you're rotating it to different angles. Now only for those objects which doesn't change the structure of the image and which doesn't make a logical sense, we do these extensive skips. So different methods which we do is we flip it vertically, then we rotate it clockwise, we rotate it anti-clockwise, and then we also rotate it to different angles, 15, 14, 45, 60. So these are angles which you can determine whether if you want more angles, you can do this. And this rotation is by a special method called get rotation matrix 2D. So first you have to get a matrix for rotation, which is a so these are all matrix multiplication. So once you get the matrix, you multiply the image matrix with this matrix, then you get a rotated image, because all these transformations are possible using these matrices. So once we get the matrix based on the kind of angle which we have, so this is the angle which we get from these list of angles. So 15, 45. So each of these angles comes in, and that is given here in this method as the what is the angle which you want to do, and why height by 2 and width by 2. So here what we are saying is we are rotating across the center of the image. So we know that HT and WD is a total size of the image. So we are trying to rotate it from the center axis, just like this. You rotate it like this to different angles, and then once this is, and see, the final rotation is through this function or this method called the warp affine, and you give the ROI, the region of interest which you want to, and give the rotation matrix which has its parameters height and width, and then you rotate it, and you append it to the final list. So using this function you get a list of different types of augmentation you can achieve using this. And then we'll see two more functions which utilizes many of these two functions which we have already seen. The first function is to extract the ROI. So this is what it does, is it goes through each row in the Excel sheet. We have seen that Excel sheet which has its bounding boxes, and then does the augmentations. And the next one is also to extract the features. So let's look at the first one.